So hello everyone, welcome to YourPedia Education. So today here I'm going to discuss with you people one more mains exam technical question, and this question was asked in the electrical engineering stream paper of CGPDTM. You know, this is a gazetted officer group A position for which they are going to conduct exam. I guess in the very next month we have the prelims, and then they are going to conduct the mains exam. And in mains exam they are going to assess your technical knowledge. So I have told you many times, the question asked in the conventional exam, they are not difficult question. This was one of the question asked in electrical domain. See, the value they have given in such a way you can solve the question with ease. So they had asked find VAB. This is the point A and this is the point B. So this question can be done in many ways. You can use multiple kind of theorems. Okay, you can use Millman theorem. You can use basically current source to voltage source transformation, and you can also use a nodal analysis. So it is up to you in what way you want to solve the question. See guys, you know, when I will start my solution, as a basic electrical engineering, we know in electrical engineering we represent signal either in the form of the voltage or either in the form of the current. So we have equivalent representation for voltage source, which is given by the Thevenin equivalent plus minus V and its resistance, that is some R. Similarly, if we are representing our source or signal with current, then we have the Norton equivalent, that is represented by some current I, and in parallel its resistance. So we represent it with R. This is R. So I am keeping this terminal as a and this terminal as a B, and this terminal as a and this terminal as a B. And both can be interchanged, or they can be transformed, or they can be converted. You can convert from voltage source to current source. You can convert from current source to voltage source. If you are doing the conversion, I will be equal to V upon R, and here V is equal to IR, and R value will be as it is, simply its position will be changed. So it means as per your requirement or as per your convenience, as being asked in the question, you can use this transformation either from voltage source to current source or reverse transformation to minimize the complexity given in your circuit. See, this is a very simple circuit, but it may seem in first go that it's a very complex circuit. No. If you are in position to understand that this transformation can be applied, then this question is reduced to a very small problem and you can solve it in very less time. See, I told you earlier there are many ways of doing, but I am solving this question as a beginner, as a person who don't know a lot of things about the theorems. I'm just taking myself to the basic of electrical engineering, right? And if I talk few terms more here, if you have resistances in the series, how you find the series equivalence? Series equivalence of the resistance is find, simply add all the resistances R1, R2 plus R3, similarly plus so on, whatever resistor you have. Similarly, if I ask you the parallel equivalence, then the parallel equivalence is calculated 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus so on up to 1 plus 1 upon Rn. So guys, these two formula I will be using, series equivalence and parallel equivalence. I told you people, I will be solving this question in a very basic way. I don't want to use here any nodal, I don't want to use here any kind of the theorem. I can expect there might be students who don't know these things. Obviously you must be knowing these all stuff, but this question can be solved without knowledge of those stuff. And second thing, one fundamental knowledge, you know, in series circuit the current is identical, current remains same and voltage divide, and in parallel the current added and voltage remains same, added or subtracted depend upon the polarity of the current sources. और पैरेलल में वोल्टेज क्या रहता है, सेम रहता है. If you know this, if you know this, if you know this transformation, and if you know the series and parallel current and voltage property, then you can solve this question. So guys, as per this question or as per this transformation, I believe I can transform this branch. This branch I can replace with some current source like this one, and that current value will be simply 20 upon that current value will be simply 20 upon 2. Again it will give me 10 ampere, and resistance as it is 2 ohm. Similarly guys, I am using the different marker for the next. Similarly, I can do the analysis for this also. If I go and convert this into current source, so I will say this will give me some transformation like this one. Again my current source will be 30 by 3, that will be again 10 ampere, and I will have one resistance that will be of the 3 ohm. So it's a very simple process. Similarly, I am going for this one. I am using the separate marker for this. I am going for this one also. You can see this transformation. So again I can do the same transformation, and I will be getting for this the transformation like this is the current source. Again it will be of the 10 ampere, 40 by 4, and this will be the resistance. So guys, what I am doing here, this will be 4 ohm only. I am transforming these voltage value in terms of the current source. So this is the basic step I am following here. See, I can solve this question with many other methods also, but I want to stick my calculation to the basic stuff only, right? So I believe if you know these all transformation, then I can remove and I can draw a new circuit, and I can write like this one. This was a current source. I guess it was given how much? It was given 10 ampere, 10 ampere. Similarly, there was resistance that was 1 ohm, and then we were getting again 10 ampere because of the transformation, and then again resistance was I guess 2 ohm, and then again we were getting because of transformation, I guess this was again 10 ampere. I am keeping this as a 10 ampere, and again we got some resistance with the transformation, that was I guess 3 ohm if I am not wrong, please cross check it. And again we got the transformation with current source, the value is 10 ampere, and again we got some resistance in parallel, and that was I guess 4 ohm, the last one transition, this is 4 ohm. So guys, can I minimize my entire circuit to this? This was point A I guess, and this was point B I guess. So now you can see these current, this current source, this current source, and this current source, they all are heading in the same direction, and I told you in the parallel current get added. So can I redraw this circuit, and instead of drawing the separate current source, I can add them all and write here 40 ampere. Similarly, there will be one equivalent resistance which will be represented by R equivalent. I will say it R equivalent. So this will be my point A, and this will be my point B as per the given original terminals. So now the point is 10, 10, 20, 30, 40. What will be R equivalent value? You can see this resistance, and this resistance, and this resistance, they all are in the parallel. I told you already, in parallel R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. So I can write it 1 upon R equivalent, since you are writing the conventional exam, so don't skip and avoid the step. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. So if you solve it, I guess you will end up getting R equivalent is equal to 0.48 ohm. I have already calculated this value. Please check, are you getting this value or not? Check it please. So up to this point the calculation is very straightforward. Check it please. So these are the some, basically the values. We can say R equivalent will be 0.48 ohm. So if this is 0.48 ohm, so I can convert it back into voltage source by using again the transformation. So it will be giving me plus minus again the value of resistance in series, and this is my A point and this is my B point. So this value I will be getting now 40 multiplied by 0.48. Let me solve it. 40 multiplied by 0.48. It will be 40 multiplied by 0.48. Somewhere it will turn around 19.2 volt. So guys, now the question asked was, I guess, VAB. The question asked was VAB. Since you can see here, there will be no drop across this resistance will be 0.48 ohm only, it's an open path. So can we say VAB is equal to minus 19.2 volt, because your B is connected at the positive potential, your A is connected at the negative potential. That is why minus term here. So answer will be minus 19.2 volt. So this answer you can calculate by using the nodal analysis also, that you can do as a practice if you want to solve the same question by using the nodal, right? You can take any particular node and apply the nodal analysis. So the final answer for VAB is minus 19.2 volt. So guys, like this, whatever question is coming there in the conventional exam, they are not difficult question. If you stick to your basic or fundamental of engineering in each and individual subject, especially like the basic electrical engineering and analog electronics, you will be in position to solve most of the question. They are not, twisted question. They are not very complex question like we expect in the objective exam. The questions are very straightforward. It's all about your imagination. If you are in position to understand what is being asked to you, and you are in position to relate the given data with your knowledge library which you have maintained while preparing, then you will be in position to solve all the question, right? So we wish you all the best. Thanks a lot.